we're going to switch gears now for the second half of this class, and we are going to be solving trig equations. You still are going to want your unit circle to help you reference, but basically what we're doing is solving equations just like you would solve an algebraic equation. So how would you solve this equation right here? Well, you would add 1 to both sides and divide both sides by 2, and c equals 1/2. Okay, that's a linear equation. How would you solve a quadratic equation like this? Well, if you remember, quadratic equations, you're working backwards to like using the zero product property and FOILing. So what times what gives us an x squared? And then my last needs to multiply to give me a positive 2, and my inners need to add up to give me the positive 3. So the 3x comes from adding these two together. So that's a positive 1 and a positive 2. And now that I have something times something equals 0, I can use the zero product property where either x plus 1 must equal 0, or x plus 2 equals 0, and x equals negative 2, or x equals negative 1. Okay. Another type of equation now is when we throw in trig. Okay? If you want to, you could always take the sign out for a second and just solve this equation. So when I add 1 to both sides and divide both sides by 2, I get x equals 1/2. Then throw the sign back in. If you want to do that, you can do that. Sometimes that's easier for some kids. Okay, so the next step then is, when does sine equal 1/2? Sine is our y value. Sine is 1/2 at 30 degrees. And sine is also 1/2 at 150 degrees. So we would say x equals 30 degrees and x equals 150 degrees. In terms of radians, that would be at pi over 6 and at 5 pi over 6. Now, there's one more twist to this. What do you know about a circle? A circle keeps going on forever and ever and ever. So while it happens at 30 degrees, it also happens at 390 degrees, and another 360 from there, and another 360 from there, because the sine wave, right, goes on forever and ever and ever and ever. So every time it's a 1/2 pi, it happens every 2 pi later. So here's how we would write the correct and final answer. We would say x is, and we're going to write our answers in terms of radians, at pi over 6 plus every 2 pi n after, meaning pi over 6, a full rotation later, which is 2 pi, another 2 pi, another 2 pi, okay? And we would say at 5 pi over 6, every 2 pi after. Again, it continuously goes around and around and around the circle. Okay? All right, let's try another one of these. 3 tangent squared of x minus 1 equals 0. So again, if you want to drop the tangent, you can, but you have to understand that the squared belongs with the x on this. So this is the same as me saying 3x squared minus 1 equals 0. Okay? So how would we solve this equation? We would add 1 to both sides. We would divide both sides by 3, and x squared equals 1/3. Well, we don't want x squared, we want x, so I have to take the square root of everything. So x equals, and now here's the trick. What's the square root of 1? both 1 and -1. What's the square root of 3? Square root of 3. Now, when does this happen? And I would highly suggest writing this on your unit circle so you don't have to do this anymore. So if we're finding the tangent when x is square root 1/2 and y is square root 3, tangent, remember, is y over x, or square root of 3 over 2 divided by 1/2, which is the same as square root 3 over 2 times 2 over 1, and that gives us the square root of 3. So if our answer is just looking for any form of positive or negative square roots of 3, this is the x and the y value that you are going to use, looking for that combination. If you are using the tangent and x is square root of 3 and y is 1/2, then we have 1/2 divided by the square root of 3 over 2, 1/2 divided by the square root of 3 over 2, or 1/2 times 2 square roots of 3, and this is when we end up with the tangent being 1 over the square root of 3. So I would write these combinations down so you do not have to continue to do these over and over again. So now look where we're at. When is tangent both positive and negative 1 over the square root of 3? Well, it is every time we have an x and y combination that looks like this. So that happens right here at 30 degrees. It happens right here at 150 degrees. It also happens right here at 210 and over here at 330 degrees. It's all the combinations of when tangent is both positive and tangent is negative. So my answer then, because I'm trying to find when the tangent of x equals both positive and negative 1 over the square root of 3, it happens at pi over 6. So x equals pi over 6, x equals 5 pi over 6, x equals 7 pi over 6, and x equals 11 pi over 6. Now, what do you notice about these points on the unit circle? 11 or pi over 6 is right here, 5 pi over 6 is right here, 7 pi over 6 is right across from pi over 6, and 11 pi over 6 is right across from 5 pi over 6. So technically speaking, these two are 1 pi away, and these two are another pi away. So what we could say for this one is x equals pi over 6 plus pi n, because they're going to repeat every pi, and x equals 5 pi over 6 plus pi n, because these two are going to repeat every pi away. So that would be our answer. So if you're a successful algebra student, this shouldn't be too difficult as the problems get harder and harder. Again, if you want to ignore the sign for a second, this is the same as us saying this. Well, how do you solve when you have variables on both sides? You want to bring all of your variables to one side. So if I'm going to bring all of my x's to one side, I'm going to add an x. X plus x is 2x. Subtract the square root of 2. And divide both sides by 2. Now, remember, I have to throw back in the sign. So when is sign negative? Sign is negative in quadrants 3 and 4. When is sign negative square root 2 over 2? At 5 pi over 4 and at 7 pi over 4. Now, are those diagonal from each other on the unit circle? They are not. So because they are not, we are going to keep them at 2 pi n. If they were diagonal from each other on the unit circle, then they would be at 1 pi n. Okay? All right, so on your own, try this one, pause it, and then you can come back and see what my answer is. So once I show the algebra, I end up here. Is that even on my unit circle? It's not. So I must need to rationalize this side first. And now this is on my unit circle. So when is cosine of x equal to square root 2 over 2? Square root 2 over 2, cosine is positive, both at pi over 4 and 7 pi over 4. They are not diagonal from each other, so x equals pi over 4 and every 2 pi after, and 7 pi over 4 and every 2 pi after. Okay? So again, we're solving algebraically, and then we are finding those spots on the unit circle. All right, let's try a little bit harder with some algebra. Again, if you want to drop the words cosine, then this would look like this. And sometimes that's just easier to see. So if I solve, I would add 2x to both sides, divide both sides by -2, and I need to throw back in the word cosine. When is cosine of x equal to -1? Cosine is my x value. It is -1 at only pi. So my answer is going to be pi and every 2 pi later. All right, let's get into some quadratics. Give this one a try, but a hint, before you do a quadratic equation, you have to get one side equal to 0. So I need to subtract 1 from both sides to get it equal to 0. Again, if it helps, go ahead and take the sign out. Just remember the squared belongs with the x. And now what times what gives me 2x squared? 2x times x. What times what gives me a -1? Well, I need a +1 and a -1. However, I need my outer and my inner to add up to a -1. So I need this to be a -2 and this to be a +1. And now that I have the zero product property, 2x plus 1 equals 0, x minus 1 equals 0. When does x equal 1? And when does x equal -1/2? And again, we're talking about sine. So we're going to have a whole bunch of answers here. Sine is -1/2 at 7 pi over 6 and at 11 pi over 6. Sine is +1 at 1/2 pi. Now, this only happens once every 2 pi. These are not diagonals on the unit circle, so they also happen every 2 pi. So this time we have 3 solutions to our x. Okay, this is our last example that we are going to do. Again, if this is complicated, take out the word cosine. Okay? Now, before you factor, always look for a GCF. And there's a common x between all 3 terms, so I'm going to factor out the x. Keep the x in front, but now I can reverse FOIL here, and this is where we're at. Okay, we have zero product property, where either x equals 0, 2x plus 1 equals 0, or x minus 3 equals 0. So I have 3 equations that I need to solve. When does cosine of x equal 0? That happens at 1/2 pi and 3/2 pi. So since they're across each other on the unit circle, they will be every pi n away. When does cosine equal -1/2? At 2 pi over 3 and 4 pi over 3, they are not diagonal, so they are every 2 pi. And when does cosine equal 1? That happens at 0 pi, so every 2 pi from there. Okay? So you have to think about your algebraic skills, and then take it a step backwards and use your unit circle.